This talk is called Maintenance Above and Beyond Cleaning to Maintain Infiltration Rates. And it's a kind of a broad, not necessarily very specific title, because I have tried to go beyond just research, and mostly with the aim of trying to solicit what your needs are and how we can develop research and education programs that can cater to the critical need of putting permeable pavements out on the landscape. Okay, so I'm going to start with a few slides that show some research that we've done. And then I also wanted to talk about some economics of permeable pavements that others have done. And what I hope where we end up after 40 minutes is a sense of what you all think are the biggest challenges in installing permeable pavement on the landscape. There's this, as an engineer, we kind of like to look at the world in, simple equations. And as I worked through extension and as we work to take science out to the community, one of the things we're beginning to really see and realize is the adoption of good BMPs by stormwater managers, by the cities, involves two critical pieces. One is education, which is what you all do, what we try to do well. The other part is regulation. And that's kind of where ecology sits and ensures that at least some minimum measures are put into the landscape to ensure a better ecosystem. But then there are also these intangibles that come with adoption to make adoption happen. And one of those intangibles, I think, is lowering the cost of compliance. So in order for permeable pavements to be more ubiquitous on the landscape, we have to find a way to lower the cost of compliance. And I'm going to ask others about lowering the cost of compliance and what's out there and some of the issues that we've seen in terms of compliance with permeable pavements. And I hope this will we'll carry that thread on into a little bit of time we have after this talk to have a conversation about it. Most of the work that we do, Lori and I, is out of the Washington Stormwater Center. We're based at the Puyallup Research and Extension Center in Puyallup. And one of the biggest reasons that I moved to the Washington Stormwater Center or to WSU was to be able to work on these amazing GSI facilities that were built in 2011 or so. So I'm going to show you some research from these permeable pavements. They're in the top left-hand side of the image. But we also do a lot of work on those other cells that you see. There are some bioretention cells, some bioretention mesocosms. I want to take this opportunity to invite you all to visit these facilities when COVID restrictions lift, hopefully sometime in the foreseeable future. Please do visit if you haven't visited already. I'd be more than happy to show you around. But because this conversation is about permeable pavements, I'm going to talk about some research we did looking at stormwater going through permeable pavements. But just as a quick background, permeable pavements are essentially a thin wearing surface on the top, which you can drive on, you can park on, and then it's got these open kind of aggregate courses below of rock and materials that can store water over time. And essentially what that does is it lets water slowly infiltrate into the parent soils at the bottom. And this is how you essentially slow the path of stormwater from ridge to stream. I'm sure all of you know this. I want to also point out a resource that hopefully you all have already seen. It's this book called Permeable Pavements. It was put out by ASCE in 2015. It's a really rich source of information put together by experts across the country, and I'll be referring to this a couple of times in this talk. We specifically focused on porous asphalt for this one piece of research that I'm going to talk about. And we have these cells that are lined, and we have some 6 porous asphalt cells and 3 traditional asphalt cells. And essentially what we did is we dosed them with storm water over 12 storm events over 5 years, added all kinds of pollutants to them, and then measured to see what came out. We had 2 objectives: to measure water quantity remediation, as well as to measure how much the pollutant loads changed over time. Again, this is not the focus of our talk, but I just wanted to bring this up to reinforce a few concepts. What we found was the porous asphalt was very good with dealing with rainfall. Over 99.5% of the rainfall that landed on those porous asphalt systems were absorbed and went down to the lower layers. And even with some of those cells getting clogged as people drove up and down those cells, the parts of those cells completely clogged. There was almost no rainfall infiltrating in those pieces. But generally, the larger part of the cell had such high infiltration rates that they were able to compensate for those clogged cells in the middle. So we published this in 2017. And we also published some work in 2019 showing how well stormwater pollutants could be removed from by these porous asphalt cells. And the note here says great for particulate matter. So total suspended solids, coarse sediments, these fractions of metals that are the total fractions of metals, all of those were fairly well removed by these porous asphalt cells. So this is just one of those plots. It's a very busy plot, so I don't expect you to pay too much attention to it. What I do want to point out is on the extreme left of this plot, you'll see that coarse sediments, total lead, total zinc, and TSS, those are the things that fell out or were removed from the water column the most. The axis on the y-axis is removal rate, so you see 0 to 100%. So we got almost 100% removal for coarse sediments, and those dropped as the particles or the pollutant sizes got smaller. Why is all of this important? Ecology has a performance goal for best management practices to treat stormwater. And for their basic treatment performance goal, you need to show that you are removing 80% of the total suspended solids from the influent concentrations. That's for anything that's between 100 and 200 milligrams per liter influent. If your influent concentrations are greater than 200 milligrams per liter, then you are expected to have a higher treatment as appropriate. For anything that's less than 100 milligrams per liter, your BMP has to have a 20 milligram per liter output or effluent. That's the maximum, that's the ceiling. So this plot kind of shows some of those, how those 12 storms fell into that whole picture. The green kind of shaded area is essentially what ecology's performance goals are for basic treatment. And so you can see all our storms fell within that green zone, suggesting porous asphalt meets ecology's basic treatment. So why is this important? It's important because, how we manage stormwater on the landscape, how is jurisdictions, how is entities that are required to manage stormwater, how they do that on the landscape is based on how ecology perceives or ecology puts out their regulations, critical regulations, by the way. So in the 2019 iteration of the Stormwater Manual, the awesome Kathy Gorham asked Ecology, hey, hit this. Will Ecology recognize the research from the Stormwater Center in the way that porous asphalt is considered as a treatment practice? And Ecology said, yes, we will reduce the depth of sand. There was a requirement for a depth of sand below permeable pavements to treat stormwater. We'll reduce that depth of sand from 18 inches to 6 inches. So with some simple math on the cost of, cubic sand and the typical widths of roadways, that's about $274,000 per mile of roadway removed through science. So I want to kind of transition away from science. So what I guess hopefully up to this point, it's apparent that the science shows that porous pavements are very good in the terms of removing pollutants out of stormwater, as well as being able to remediate the water that falls on them in terms of water quality and water quantity. So the question is, if they're so great from a scientific perspective, why aren't we seeing permeable pavements everywhere? And I think, and as you all probably understand, there are some issues out there in terms of how people perceive permeable pavements. And one of them is the cost of installation and the cost of maintenance. So the rest of the few minutes I'm going to speak will be kind of addressing those two issues. I am not an economist. I'm still a hydrologist, but I really do have an appreciation for people who can talk about the economics of compliance and economics of stormwater treatment. So here are some typical installation costs for porous asphalt and pervious concrete. These are the two that we tend to focus on. These are all resources that are available to most people. So if you don't have a way to get to, this is from that document, Permeable Pavements. These are some typical installation costs for porous asphalt and pervious concrete. $6, $8 per square foot. The range from 4 to 8, 6 to 10. These are data that were current as of 2013. So I'm guessing things have changed since. So with a pinch of salt, those numbers hopefully will be at least give you a sense of what the ballpark numbers are. Another resource that I want to point people to is the Water Environment Research Foundation's BMP LID whole life cost model. This is also somewhat dated 2005, but the model is still pretty good, and you can update. It's pretty easy to update with numbers that are current today. So I played around with this model. I wanted to just do a ballpark estimation of what an acre of porous asphalt would cost at about $6 a square foot with some medium frequency of maintenance. And so here's another, hopefully this is showing up. Lori, can you see these numbers?
Yes.
Okay. So this is it's again a very busy slide, but what I want you most all to appreciate is that there are some tools out there to help kind of parse out some of these costs and at least do some simple cost comparisons. So this says it's $460,050 for an acre of porous asphalt at $6 a square foot. There were some numbers that I could play around with in terms of maintenance. So if you did a inspection, reporting, and information once a year, you did litter and minor debris removal from these pavements twice a year, and sweeping twice a year. Cost of maintenance is about $2,430 a year. And then cost of replacement over once every 35 years gives you about an annualized cost of about $9,957. Again, these are just ballpark costs. This is not, I'm not trying to make the suggestion that these are the costs that every jurisdiction will be paying. I know there's a lot of uncertainty and a lot of um, issues that need to be also quantified, but that tool is pretty useful and maybe a resource that people can use. Okay, so this is from that permeable pavements document. This is what they approximated permeable pavement maintenance costs to be. That $2,400 is very similar to the number that I came up with. And of course, it's not a coincidence. I tuned my calculations to show that it's doable, but also that so my number was tuned to match what the ASCE table said. So, but yeah, so these are some numbers for some other BMPs as well: green roofs, bioretention, street trees. But what does all of this mean? We're talking about actual costs. We're talking about actual numbers that jurisdictions have to pay. And these are kind of high numbers. They're definitely not cheap, but what has been missed in a lot of those conversations, and we hear it all the time, permeable pavements are just too expensive to put out there. Bioretention is great, but who's going to do the maintenance? It's a lot of work. All those costs and those issues associated with the dollars and cents of these green practices is important. But what's also being missed is that there are other costs that are not being accounted for, that need to be accounted for. And at this point, all those costs are in the realm of economists, of people who do ecosystem services. It's a lot of calculations and metrics that aren't in the common vernacular. It's not part of what a PWD manager is telling his boss or his elected officials. So I wanted to bring up this one study by Zhao et al. It's from Corvallis, Oregon. And what they did was they came up with this analysis of what it would cost the city of Corvallis to retrofit all their green roofs, retrofit all their roofs to green roofs and permeable pavements. I'll say that again. What it would cost the city of Corvallis to retrofit their roofs and streets with green roofs and permeable pavements. And the total cost of that retrofit was calculated to be $453 million to $502 million. Those are all pretty big numbers. Then what they did is they also accounted for all these other costs that are typically not accounted for: carbon sequestration, stormwater infrastructure improvement, amenity values, habitat creation, stormwater purification, avoided stormwater infrastructure costs, energy savings, food production, and air quality benefits. And these, of course, are not numbers that we typically calculate. And what they found is that if you included all those costs, by converting your roofs and your streets to green and permeable pavements, you're offsetting, or you're claiming $210 to $290 million in benefits over 10 years. And this would include $150 million damages from floods. So they were saying if the 100-year flood occurred in this time, and it would incur about $150 million, you would still be able to accrue $210 to $219 million in benefits over that period. If there was none, if that 100-year flood did not occur in that time, the total dollars in benefit would be $540 million to $552 million. So these are like really staggering numbers to think about, and the biggest issue, I think, and this is kind of the part that I'm starting to appreciate more, is the biggest issue is how do we get those metrics into the conversation when we're talking dollars and cents at the city or the municipality level. All right, so I'll get off that soapbox for a little bit, and hopefully I'm still meeting your needs in terms of what you came to. Here are some quick design suggestions. All of these are out there, and I just put a few together for our conversation today. One is to build, when you're building permeable pavements, when we're building permeable pavements, it's okay to mix part pervious, part impervious, as long as you're not going over that 1.5 to 2 ratio between impervious to impervious. So remember I said that the pavements at WSU Puyallup, where people were driving across the parking lanes, they were completely clogged, and they were in fact impervious like drive lanes. But the rest of the system was pervious enough to be able to manage or to offset that imperviousness. So how that translates, whether that translates into driving lanes that are impervious with parking slots that are pervious, or some other like combination, that's fine. People have shown that it does work. Another thing to consider is when people are repairing or reinstalling some piece of gray infrastructure, use that opportunity to also install green infrastructure. Again, this is, I know I've seen this a lot. I know Ryan's on the call. The city of Puyallup has been doing this too, and has been having great success putting in pervious pavements where when they're doing gray repair and reinstallment. This is an easy one. Ensure that your pavement is the highest point on the local terrain. And if that's not doable, install the barrier between dirt and pavement. Turns out that dirt is the biggest, is pervious pavements kryptonite. So keeping dirt off pervious pavements is almost critical. Some maintenance suggestions is having a maintenance plan from the outset. The maintenance plan is almost the most critical part of the system. And so having a plan right off the bat is critical. Make sure those plans are different for homeowners versus jurisdictional crews. I'm very curious if folks here who work for jurisdictions have a separate plan for the two types of communities. And of course, the most obvious, keep sediment and organic material off pavements. But what we are finding is that education, and getting the education to the right people is almost the most important part of getting permeable pavements out onto the landscape. And who and how best to meet those people's education needs is not something I know completely, and I'm really looking to the community, people like you all in this call, to help us answer those questions. Who do we need to be talking to, and what works best for them? So we have a bunch of school kids that come through our facilities, and they look at our permeable pavements, look at our green stormwater infrastructure research. And I hope that we're making a difference, because I know a lot of them are going to be kind of critical to how a lot of this goes out in the coming years. We also have we have some resources at the Stormwater Center, including a operations and maintenance training program. It's a 3 modules in the operations and maintenance. We have 5 modules in LID design. We offer a certificate at the end of that. And what it does is it covers the basic principles of operations and maintenance of green stormwater infrastructure. And if any of you have taken it or are planning to take it, let me know, and let me also know if you find it useful. It's mostly background information, but it all puts it all in one place. And I think for anybody that's going out to install green stormwater infrastructure practices or is thinking about it, this would be a good And with that, I think this is my last slide. I have to make sure I acknowledge all our partners. And one partner that's not mentioned here is the city of Tacoma, who have really been a great ally for us in terms of doing research and going out and trying to do impactful work.